Hello and welcome dear student. Today we will solve question number 4th of question 1 exercise 2.2. So our question is find the zeros of the following quadratic polynomials and verify the relation between zeros and coefficient. Our polynomial is 4u square plus 8u. Okay, so we write here suppose fu is equal to this because this polynomial is in the variable of u, so we write fu is equal to this. Now factorize 8u square plus 8u square plus 8u. So here we will take 8u common in since it is in the both terms, so we write 8u in a bracket u plus 1. So for obtaining zeros we write fu is equal to 0. Okay, so we write 8u u plus 1 equal 0. So u plus 1 equal 0 we write, because when we transpose 8 to that side it will be in here is a divided form, and also when we transfer to the right side then it will become divide, and when we divide 0 by 8 we will get 0. So here you can write u is equal to 0, or you can say u plus 1 is equal to 0. Okay, so you write u equal 0, or u equal, when we transpose plus 1 to that side it will minus 1. So u is equal to 0 and minus 1. So we suppose alpha is equal to 0 and beta is equal to minus 1. Okay, now here is also and one again question is we have to do verification. Okay. So first in the verification our first condition is alpha plus beta. So 0 plus minus 1 you will get minus 1. Also minus b upon a, because alpha plus beta should be equal to b minus b upon a. So here you can see here the value of a equal 8, b equal 8, and also there is not c, so we write c is equal to 0. You can write plus 0. So we will write here minus and 8 upon 8 you will get minus 1. So therefore we write alpha plus beta is equal to minus b upon a. Okay, so our first condition is verified. Now our second condition is alpha into beta equal to, so 0 into minus 1 you will get minus 1. Okay, minus 1. So also c upon a is equal to c, the value of c is 0 upon 8 you will get alpha into beta is equal to 0. Sorry, when we multiply 0 to any number you will get 0, and also when you divide 0 by 8 you will get 0. Therefore we write the second condition alpha beta equal to c upon a. So our second condition is also verified, so we can say that there is the relation between zeros and the coefficient is verified of that question. Again our question fifth is t square minus 15. T square minus 15. Okay, so our question is t square. You can look here, our question is t square minus 15. Here the variable is t, so we write here suppose ft equal t square minus, it is the question fifth, minus 15. Okay, you can see here a equal 1, also b equal 0, because you can write t square plus 0 into t minus 15. Okay, and also c is equal to minus 15, it is a constant term. So for obtaining zeros of this polynomial t square minus 15 you will write ft is equal to 0 and t square minus 15 is equal to 0. Okay, you can write here t square minus under root 15 square. Okay, because under root 15 square is equal to 15. Okay, So a square minus b square you can identify here. So in one bracket you will write t minus under root 15, and in a second bracket you can write t plus under root 15 equal to 0. So RHS will be 0 if either t minus under root 15 is equal to 0, either or t plus under root 15 is equal to 0. So we write t minus under root 15 is equal to 0, or t plus under root 15 is equal to 0. So t is equal to under root 15, or next t is equal to minus under root 15. So t is equal to under root 15 and minus under root 15. So suppose alpha is equal to under root 15 and beta is equal to minus under root 15. Okay, so now we write the verification between zeros and its coefficient. Okay, so our first condition is alpha plus beta should be equal to minus p upon a. Okay, so alpha is equal to, you can see here, alpha is equal to 15, and again the value of beta is equal to minus under root 15. So when you solve this, you will get alpha plus beta is equal to 0. Okay, and again now find out minus b upon a. You can see here the value of b is equal to 0. Okay, and also the value of a is 1. Okay, when you will divide 0 by 1, you will get 0, and minus 0 means you can say that 0, because 0 has not any sign. Okay, next line, alpha into beta, the product alpha into beta, alpha 15 into beta 15 in a bracket minus 15. So when you will multiply minus, so here you will get minus, and minus 15 minus square, so it will be minus 15. Okay, now c upon a is equal to, the value of c is 0, sorry, minus 15 upon, and the value of a is 1, so you will get minus 15. Therefore the second condition is also verified, alpha beta is equal to c upon a. Okay, so our fifth question is also completed. Now our sixth question, you can see here, our sixth question is 3x square minus x minus 4. Okay, 3x square minus x minus 4. Now suppose fx is equal to 3x square minus x minus 4. Okay, now here a is equal to 1, sorry, a is equal to 3, b is equal to minus 1, and also c is equal to minus 4. So now for obtaining 0, you will write fx is equal to 0, 3x square minus x minus 4 equal to 0. Now split the middle term in such a way that the product of the first and third term will be equal when you split this minus x in a two terms. When you will product that 3x square minus 4, you will get minus 12x square, and also when you sum, then you will get minus x. Okay, so now let us solve this question. First you write 3x square minus 4, and again you can write here minus x. Your answer will be when you add minus x, and also your answer will be minus 12x square when you multiply. Okay, so you can write 4 into 3 minus 4x plus 3x. Okay, so now look here, you can see here x is common in these two terms. Also there is no anything you can see here that will be, you can take common from these two terms. So you will get only common in these two terms, only one. Okay, now take out x and you will get 3x minus 4. Also plus 1, you will get 3x minus 4 is equal to 0. Okay, in these two terms there is common only 3x minus 4. So take out common 3x minus 4, you will get x plus 1 in one bracket, another 0. Now RHS will be 0 if 3x minus 4 equal 0, either x plus 1 will be 0. So 3 minus 4 equal to 0, or x plus 1 is equal to 0. So you will get x is equal to 4 upon 3, and another question minus 1, x plus 1 is equal to 0. So when you transpose plus 1 to that right side, you will get minus 1. Okay, so here you will get alpha is equal to, you can say 4 upon 3, and also beta is equal to minus 1. Okay, so our next term we have to verify. We have to verification. Now first condition, alpha plus beta should be equal to minus b upon a also, and the second condition, alpha into beta should be equal to c upon a. Now look, 4 upon 3 plus minus 1. Okay, now solve this. Whenever you solve, you will get 4 minus 3 upon 3, that means my 1 upon 3, and also minus b upon a, you will write minus b. What is the value of b? You can say value of b is minus 1 upon, and the value of a is 3. You will get 1 upon 3. Therefore you can write here alpha plus beta is equal to minus b upon a. Okay, and also our second condition is alpha into beta, means the product of these two roots. You will get alpha is 4 upon 3 into beta is also minus 1. Okay, now solve. Whenever you solve these two products, you will get minus 4 upon 3, and also c upon a, and c, the value of c is minus 4 upon the value of a is 3. So you can say therefore alpha into beta is equal to c upon a. So our first question is fully completed. Now we will ahead on the second question. Now you can see here our second question is find a quadratic polynomial. Each means these six numbers, or you can say these 6 questions, each with the given numbers, these are the numbers, as the sum and the product of zeros. So in this question, the question is says about the question says about all the question that in a first question, the first number represents the sum of the zeros, and also the second number minus 1 represents in a question 1 product of the zeros. Okay, and we have to form a quadratic polynomial. So our second, we can write second and first question, given or you can write here, suppose the zeros of a required polynomial are alpha and beta. Okay, now this statement you will write in all question. Okay, so first question, now solve. In a first question you have to given first line, you will write given alpha plus beta is equal to 1 upon 4, and also alpha into beta is equal to, it is given minus 1. Okay, alpha plus beta is equal to this. So we know that whenever you have to given two zeros, our polynomial will be, we know that a required polynomial is fx is equal to x square minus alpha plus beta x plus alpha beta. Now x square minus alpha what is the value of alpha plus beta? 1 upon 4 x and also plus and minus 1. Okay, so this is your answer, this is your answer. But in the but you want to whenever you want to match your answer in your textbook answer sheet, then you will get, then you can solve this question in another one step also. So first you will take 4 as a LCM, so you will get 4x square and plus minus x, okay, and minus 4. Okay, so 1 upon 4 and in a bracket 4x square minus x minus 4. Okay. So you can write the polynomial is 4x square minus x minus 4. So your answer can be this, or also can be this. These two answer are the same for the sum of the roots, the sum of the zeros and the product of the zeros. Okay, here you can observe that it is only constant. 1 upon 4 is only constant. Okay, so you will take only the quadratic polynomial this, so your answer will be this. Means you have to get these two answers, 4x square minus x minus 4 and also x square minus 1 upon 4x plus minus 1. Our second question, in a second question given alpha plus beta and also product alpha into beta. Okay, so in a second question, root 2 1 upon 3, root 2 1 upon 3. Okay, alpha plus beta is equal to root 2 and also 1 upon 3. Now, so our required polynomial, we know that fx is equal to, for a quadratic polynomial, you know, x square minus alpha plus beta x plus alpha beta. Okay, now write x square minus what is the value of alpha plus beta? Root 2 x and also plus 1 upon 3. You can solve, this is your answer, but also you can say another answer. Take the LCM of this, take the LCM from these three terms. You will get 3 as LCM. You will get 3x square minus 3 under root 2 x plus 1. Okay, you can write here 1 upon 3, 3x square minus 3 root 2 x plus 1. Okay, so you can write here in according to your answer sheet, the polynomial is 3x square minus 3 root 2 x plus 1. Okay, third question. In a third question you have to given alpha plus beta. Alpha plus beta is equal to 0 0 and alpha into beta is equal to under root 5. Okay, so we know that for making a quadratic polynomial, when the sum of the zeros and also product of the zeros are given, so fx is equal to x square minus alpha plus beta x plus alpha beta in product form, x square minus 0 into x plus under root 5. You will get x square plus root 5. Okay, so it is our polynomial, x square plus under root 5. Okay, in this there is only one answer, because there is no any term is fraction. Our fourth question, in a fourth question given you can see our fourth question given 1 1 means alpha plus beta is equal to 1, and also alpha into beta is equal to 1. Alpha into beta is equal to 1. So we know that fx is equal to x square minus alpha plus beta x plus alpha beta. You can take any more variable at the place of x. X square minus 1 into x plus 1. So you will get x square minus x plus 1. Okay, it is your answer. Our fifth question, it is given alpha plus beta minus 1 upon 4, alpha into beta equal to 1 upon 4. We know that fx is equal to x square minus alpha plus x plus alpha beta. X square minus the value of alpha plus beta is minus 1 upon 4x plus 1 upon 4. Okay, so you can write here minus x square plus 1 upon 4x plus 1 upon 4, because there is two terms which involve fraction. So take the LCM. 4, you will get 4x square plus x plus 1. So 1 upon 4, 4x square plus x plus 1. Okay, so the polynomial is 4x square plus x plus 1. So your answer is 4x square plus x plus 4, and also you can say x square plus 1 upon 4x plus 4, 1 upon 4. 6. In a question 6, it is given that 4 1 means given alpha plus beta is equal to 4 1. We know that fx equal x square minus alpha plus beta x plus alpha beta. Okay, so x square minus 4x plus 1. So it is our answer. So thank you for watching my video. We will meet in the next video for taking next topic. Goodbye.